Hey guys, welcome. I'm so sorry I can't be there to see your bright and shiny faces looking up at me as we take our notes together. But anyway, I'm there in spirit. Um, so yeah, anyway, you should have your guided notes sheet in front of you, and we are going to go through it uh, today. And I'm going to show you and explain everything that you need to do, and you'll just fill out your notes as you go, and we'll have a great time. So, solving inequalities part 1. First, we need to know what the symbols mean, right? We see these symbols all the time. It's very important that we understand what the less than is, the greater than, what all that is. So, that first one, that says x is less than. All right, x is less than. I'm going to try as I go through this to give you enough time to hopefully write things in. So please try not to fall behind. Try not to miss anything. The next one is, of course, the other way. X is greater than. X is greater than. And then the third one will be x is less than or equal to. So you'll notice it's got that little bar thingamabobber underneath it. That's like half an equal sign. So it's combining the two symbols, the less than symbol and the equal to symbol, into one to make it x is less than or equal to. And then the last one, of course, x is greater than or equal to. So no surprise there. All right, so again, I'll give you a little bit of time just to make sure you've got this all filled in your notes. Because who knows, maybe I might come by next week and check out that you filled them all out. All right. Anyway, Tennessee's really nice. It's really great up here. I'm on a plane right now, so this is not live. Anyway, I'm actually recording this on Tuesday. Don't get confused if it's backwards. X is less than 5 is the same thing as 5 is greater than x. Yeah, that was a smooth segue, by the way. X is less than 5 is the same as 5 is greater than x. So these two things mean exactly the same thing. Try not to get too bogged, down with the details. Basically, what it comes down to is the way that opens up, way that sign opens up. It's always opening up towards the bigger side and it's pointing away from whatever is the smaller side. So this case, it's saying 5 is bigger than x. In this case, it's also saying that 5 is bigger than x. So both versions mean the same thing. When I was growing up, you might have had a teacher say that it kind of is like a gator mouth. So like, you got your little gator teeth, and then here's your alligator. Cool beans. Cool beans. Anyway, little legs. All right. I'm getting a little bit carried away now. Anyway, x is less than 5 is the same thing as 5 is greater than x. So just keep that in mind. It's always opening up towards the bigger end. Oh, I lost my train of thought. Yeah, because the gator would eat the bigger half, right? The gator would want to eat more, so that's why I was always trying to eat the bigger side. So it wants to eat 5 because 5 is bigger than x in both cases here. Anyway, statements of inequalities. So these are statements, sentences that we are going to translate into an inequality. These are very easy quiz questions, so hopefully they're not too confusing. But the first one, I studied for at least 4 hours last night. So x is going to be representing us studying, and we studied for at least 4 hours, which means we studied for 4 hours or more, right? So the hours I studied is greater than or equal to 4 hours. Now, it's not just greater than, it's greater than or equal to because it's at least 4 hours. So it is including 4 hours exactly. But of course, it's also including more than 4 hours. So the number of hours we studied is greater than or equal to 4 hours. Don't worry if I'm erasing it. I'm showing it back up on the thing as well. So yeah, I will write it down first, but I'll erase it to just to clear up the screen a little bit. So I studied for more than 4 hours last night. So this is very similar, but it's a little bit different. So the number of hours we're studying is more than 4 hours. So it's greater than 4. Now, this does not have the equal to part because it doesn't include 4 hours. We studied for more than 4 hours. Does not equal 4. We did not study for exactly 4 hours. We studied more than 4 hours, just strictly greater than, not greater than, or equal to. So it's very similar to the last problem, except for the fact that it's not including the 4. Okay, the third one. There are no more than 2,500 people at the theme park. So there are no more than 2,500 people at the theme park. So the people at the theme park is going to be X here, and there's no more than 2,500. So that means, or 2,500, however you want to say that. That means that the number of people at the park is 2,500 people or fewer. So the number of people at the park has to be less than 2,500, but it's also, could it be 2,500? Can I have 2,500 people, or is it just strictly less than 2,500 people? It says there are no more than 2,500. So that means it could equal the 2,500 as well. So X is less than or equal to 2,500. We might have 2,500 people in the theme park. We definitely have less than, but we could have exactly 2,500. We just don't have more. We can't have more than 2,500. So it's X is less than or equal to, because it's definitely less than or exactly the same. And then the last one, there are fewer than 2,500 people at the theme park. So again, very similar to the third one, except for the fact that it does not include the 2,500. It is strictly saying we have less than the 2,500 number. We are not including that number. It is strictly fewer than, not less than or equal to, just less than. So that one is just X is less than 2,500. I feel like I've said 2,500 a lot. You guys think I said 2,500 a lot? I feel like I've said it a lot. So anyway, moving along. Well, that's a real shame. Okay. Well, those are the answers. But I'm not going to redo this. So here's what I'm going to do instead. See, you can see, look, Tuesday at 16:42. That's when I did this. Animations, go away. We're going to make that show up. We're going to make this show up. I'm not editing this as we, I have to see if I can edit this out. That'd be great. If I can't, then you're watching and I apologize. All right, but we're just going to do this. All right. I still missed them. Okay. You guys probably noticing me not actually clicking anything. All right, I don't know. Boom, like it never happened. The temperature is over 100 degrees. So the temperature, X, is over 100 degrees. X is more than 100 degrees. It's not equal to 100 because it is definitely over 100. So it's just X greater than 100, not X greater than or equal to 100. The next one, you need at least 5 years of experience to work here. So to work here, you have to have more than 5 years experience, but could you have exactly 5 years? It says you need at least 5 years of experience. So yes, you could have more than 5, or you can have exactly 5. So that is X is greater than or equal to 5. The third one, the team needs at least 10 yards for a first down. So the team needs at least 10 yards for the first down. So we need to have more than 10 yards. Can we have exactly 10 yards, though? That's the question. It's more than 10 yards. And yes, it is. We can have exactly 10 yards. At least 10 yards means 10 yards or more. So we are going to include it with the greater than or equal to sign rather than just the strictly greater than. The movie theater holds at most 310 people. So the movie theater holds at most 310 people. So it can hold less than 310 people, but can it hold exactly 310 people? At most 310? Yes, it can include 310. So it's going to be just less than or equal to 310. All right, and then one more. I cannot make less than a 70 on my next test. So the score that I need to make on my test cannot be less than 70. So it has to be more than 70. Can it be equal to 70, or does it have to be strictly more than 70? I cannot make less than a 70. So I could make a 70, right? I could make that a 70. So I will include it greater than or equal to 70. So now we can see all those answers pop up and in no particular order because they're just going to show up wherever, however they want. All right, there you go. Those are the answers for those problems. Again, those are very, very good type of quiz questions. All right, so now we're going to move on to graphing inequalities. So graphing inequalities, you have a number line. I don't know if I've put this number line on your guided notes because, spoiler alert, haven't made them yet. But you'll see if you have them or not. If you do have a number line, that's great if I provided that for you. If not, it's very easy to draw. It looks like this, has numbers on it. So we're going to graph x less than 3 here. So notice it does not equal 3. It is just normal less than, not less than or equal to. So what we're going to do is we're going to go to our 3 on our number line, put a circle on it. Now I'm going to leave that circle open rather than shading it in like this. When I leave it open, an open circle indicates that it is strictly less than or strictly greater than. So you might need to make a note of that somewhere. If I shade my circle in like this, it means I'm including that value. That would be something like less than or equal to or greater than or equal to. I would be including that value. Now, since it's just less than and I do not equal 3, I'm leaving that open circle. Okay. Now, it is less than 3. X is less than 3. So I have to shade in all the numbers that would be less than 3. So I would basically just shade this entire side of my number line and then draw a little arrow to indicate, hey, that it goes all the way. So what we're saying by doing that is all the numbers that I have shaded in are solutions to this inequality. I can plug any of those numbers in for x, and I would have a true statement. So 2 is less than 3, 1 is less than 3, 0 is less than 3. Even the decimals like, 0.5 would still be less than 3. So I'm shading all those numbers in because they can all be solutions. They are all technically less than 3. So now let's graph x is less than or equal to 3. So I mentioned this before. We're going to have a circle on 3, but because it's less than or equal to, we can actually equal that value. We're going to shade in that value. So remember, when you shade something in, it means you're including it. So we didn't shade in 3 before because we didn't include 3. We were just less than. But now this one, we are including 3 because it's less than or equal to. So we do shade it in. And of course, everything less than 3 also gets shaded in. So we'll shade in everything to the left-hand side and draw an arrow to indicate that we would go the rest of the way. All those numbers would fit that inequality, including the value 3. So leave this here just for a second. If anybody is taking a second to finish drawing it, I'll give you a second. I know we've talked a lot here. All right. So hopefully you got those shaded in. Now let's practice graphing a few. So do I have a number line on this? I do not have a number line on this. So we'll have to see. But I'll go ahead and make a number line for us. So our number line, I'm noticing that I'm looking at the number 15. So I'm just going to make sure I have 15 in here. And then I'll just go with the values around 16, 17, 18, 19, whatever, right? And then 14, 13, 12, 11, 10, whatever. Okay. Now we're going to shade this number line in. So I'm going to go to 15, put my circle there because obviously I'm talking about that value. But I'm shading less than 15. And I am not going to include 15 because it's just less than and not less than or equal to. So it does remain an open circle. I won't shade that in. But I do need to shade everything that's less than 15. So I'm going to shade in everything to that side, and including the arrow to make sure I indicate that I'm going the rest of the way. All right, I'm going to go ahead and do these other ones. So I think you guys mostly probably get the point. So let's try and fill this in quickly so we can finish the rest of this. -2, -1, 0, -5, -6, -7. By the way, in case you didn't know how a negative number line works, that's how a negative number line works. We have to go to -4, and we have to circle it. And since it is equal to, right, greater than or equal to, we do, in fact, shade in the circle there at -4. Now it says x is greater than or equal to -4. So we have to shade all the numbers that would be greater than -4 as well, which is going to be everything to the right-hand side here. So, and the arrow to indicate that it goes the rest of the way. All right, so far so good? Great, good to hear it. Let's see what the third one is. Third one is greater than 85. So we're going to draw our number line. We're going to throw 85 here. We know, get some numbers around it. 86, 87, 88, etc. 89. We can do 84. We can do 83, 82, 81. All right. We're going to go ahead and make sure our circle's on 85. And now we are not going to shade it in. We're going to leave it open because it is just greater than, not greater than or equal to. So it's an open circle, but we need to shade in all the stuff that's more than 85. So that's 86, 87, 88. That's everything on the right-hand side. Shading that all in, and the arrow. We're good to go. All right, and I believe we got one more. I'll go ahead and do this last one, and I'll give you guys a second after the end to finish your graphs. If any of you are behind, that's cool. You know, I'll give you a minute. I don't know how fast or slow I need to go, so because I'm not there. I'm in Tennessee. So, and if you're wondering, I'm having a great time without you. So x is less than or equal to -23. So we're going to throw in -23. Now be careful about how you number your number line here, because you know the greater than side, -22, -21, -20, it kind of goes backwards from how your positive numbers go. So just be aware of that. Be very careful as you fill it in, because obviously if you number it wrong, you're going to do everything else wrong. All right, x is less than or equal to -23. So going to -23, and we're going to shade that in because it is less than or equal to. So it could be 23. So we're going to include it. We're going to shade in the -23. But we also need to shade in everything that's less than 23. So all the numbers that are smaller than 23 are technically the bigger negatives. -24, -25, -26, etc. All those that go to the left-hand side. And there are your graphs. For practice a few. Those are those problems. I will give you about a couple seconds to finish drawing if you need any more time drawing these in before I move forward with the next problems. Okay, the screen's not frozen. I'm just chilling. Are you good? Okay, raise your hand if you need more time. Psych. All right. Find the solution set to the inequality. No, I'll go back. I'll just, if anybody needs a second. Psych. Okay, find the solution set to the inequalities. Now, these are the more fun ones, in my opinion. It's just like solving a normal equation, just like a normal equation. Exactly like a normal equation, but with like a small little twist. Okay, we'll talk about that twist when we see it. But for now, let's just treat it like a normal equal sign, like a normal equation, and see what we get at the end of a problem. So here we're going to find the solution set to 3x plus 5 greater than or equal to 20. So what we're going to do, I like to draw my line just like it was an equal sign, just like an equation. Same thing as an equation. Okay. Now to solve for x, I'm going to have to move that 5 and also move that 3. We've talked about this. the first thing that we're going to need to move is that 5. So since it's adding 5, we're going to move it by subtracting 5. So we're going to do that to both sides. The left side, the 5 is going to disappear. It's going to go away. We'll just bring down the 3x. Remember, it's less than or equal to. I almost wrote an equal sign because I'm so used to it. It's not an equal sign, though. It's still greater than or equal to. And on the right side, we have 20 minus 5, which makes 15. All right, so again, that first step, just like a normal equation, subtract 5 on both sides. So now we need to get rid of that 3. So since it's 3 times x, we will get rid of the 3 by dividing by 3. 3 divided by 3 cancels out, leaves us with x. Remember, it's still greater than or equal to. It's not a regular equal sign. It's just greater than or equal to. And then the right-hand side, we have 15 divided by 3, which is 5. So our solution to this one is x greater than or equal to 5. Now, a lot of times on a test or something, they'll ask you to graph this, just like we did in the previous set of problems. But, I'm not going to ask you to graph it today because we've already gone through 10 graphs. We don't need to do that anymore. But you get the idea. You would probably have to graph this as well on a test. But for now, I want to make sure I'm just pointing out the fact that we can solve these problems, just like a regular equation. So this would be the exact same thing as an equation. There's no twist in this problem. There's a twist in some other example, but not in this example. This example, completely normal. Okay, I do need to erase this. So kind of out of luck here. I'm just I put the problems on the same slide. So all right, now this one, I'm going to write it over here. We have x over 2 minus 4 is less than or equal to 11. So I'll go ahead and say, the twist is not in this problem either. Like I said, when we get to it, I'll tell you what it is. Some of you might already know what it is if you remember this from previous years. But yeah, it's not going to be in this problem. But we are going to treat this problem just like a normal equation, but we're going to keep our sign less than or equal to. Now, the first thing I need to do is get rid of our 4, and then I'll get rid of that 2. To get rid of the 4, same thing that we did with the 5, except for, this was a plus 5, so we subtracted it. But since this is a minus 4, we'll have to add 4 to both sides. Adding 4 to both sides, we cancel it out on the left. We'll just bring down the x over 2. Don't forget it's less than or equal to. And 11 plus 4 is 15. So far, so good. Now I got to get rid of that 2. Now to get rid of that 2, it's, right now it's x divided by 2. Again, opposites. So the opposite of dividing by 2, you guessed it, multiplying by 2. Multiply both sides by 2, we end up with x by itself, still less than or equal to, and then 15 times 2. 15 times 2 is 30. And just like a normal equation, we have our solution, we have our answer. So I'll leave that up there just for a few more seconds in case you're still writing it down. And then we'll move on to our final few equations. We've got a couple more before we wrap things up. All right. Hopefully we're all done by now. Hey, if your head's down, you need to pick your head up. I can see you. I know people are falling asleep. So hey, quit it. This is important stuff. Okay, I might grade these notes later on. Pretty easy grade if you ask me. So I think it's the last two. Oops, spoiler alert. Anyway, these last two do have that twist that we need to talk about. So let me work out the first one. We have negative 5x minus 7. Negative 5x minus 7. Greater than or equal to 33. So just like a normal equation, okay? For at least now. So what we're going to do, we got to get rid of the 7 and got to get rid of the 5. Hold the negative 7 and the negative 5. So just like in the previous problems, we'll get rid of the 7. We'll add 7 to both sides. So we can get rid of it. We'll bring the negative 5x down. It's still going to be greater than or equal to 33 plus 7 is 40. All right. Now comes the interesting part. So now I got to get rid of negative 5. So just like in a normal equation, to get rid of the negative 5, I would divide by negative 5. Okay. But notice what's going on now, right? Is I am taking the negative that was here and I'm putting it onto this side. So what's going to happen is I'll have a regular x. It's not negative anymore. I'm actually moving the negative over here. So because I'm dividing both sides by a negative number, I'm relocating the negative, so to speak. And when I do that, I have to adjust my inequality sign because now x is going to be on the smaller side. X is less than or equal to. And then, 40 divided by negative 5 makes negative 8. So the trick here is if you divide by a negative on both sides, you have to remember to flip your inequality sign. So it was greater than or equal to, but now it's less than or equal to because of the movement of our negative. So be very, very aware of that. Be very, very careful because that is usually why people get the problem wrong, is they forget about flipping the sign. And this is a very rare occurrence. It only happens when you divide or multiply by a negative number on both sides. Okay. It doesn't happen just because a negative's in the problem. There could be negatives in the problem and it would be fine. It's only if you divide both sides by a negative number or if you multiply both sides by a negative number. You can still have negatives, but it's only, like I said, if you divide both sides by a negative or multiply both sides by a negative. So just be aware of that. Be very careful about that. All right, let's talk about this last problem. So our last problem, we have negative x over 3 plus 6 greater than 14. So just like a normal equation, okay, we'll start by subtracting 6 on both sides. Bringing down, we have negative x over 3 is greater than 14 minus 6. 14 minus 6 is 8. All right, so just like a normal equation, right? Just subtracting the 6 because we had plus 6. That's gone. Just, bringing down the negative x over 3. Bringing down the 8. And the sign is still the same. So we subtracted both sides, but that's fine. There's nothing wrong with that. The sign stays the way it was. But in the next step, okay, I have a negative x over 3. There's more than one way to think about this problem, but I'm going to go ahead and tackle both birds with one stone here. I'm going to multiply both sides by 3 so I can cancel out the 3, but I'm also going to multiply both sides by a negative. So technically negative 3 on both sides. Now the reason I'm doing that is because a negative times a negative will make that left-hand side positive. So I'm going to cancel the negative and the 3 out at the same time if I multiply by a negative 3 to both sides. So the 3's cancel, the negatives would cancel, leaving me with x on that side. And then 8 times negative 3 makes negative 24. Now because I multiplied both sides by a negative number, I do flip the sign. It's the exact same rules for when I divide by negative. Most of the time we're used to dividing by negative, and you could have done this problem in that way where you end up dividing by a negative. But like I said, I went ahead and did both steps at the same time here. So if you multiply both sides by a negative, or if you divide both sides by a negative, you will need to flip your sign. So in this case, it was greater than, but now it's flipped to less than. So please remember to do that. So I left a note there, but I wrote over it. So I'll give you a second to write the rest of this problem down. If you need that time, then I'll show you that little note. And you can add that little note to the end of your notes. Okay? So let me go ahead and erase some of this just so I can show you. So write this down. Put a star next to it, circle it, highlight it, whatever you want to do. It is the most important rule when it comes to these inequality problems. Okay. When you're trying to solve them. If you ever end up dividing or multiplying both sides by a negative, you need to flip your sign. Okay. So flip the sign when dividing or multiplying both sides by a negative. All right. Yeah, that's gonna cover it. So I hope you guys enjoyed. I know I did. So I will see you guys next week. You will have some work, a practice worksheet tomorrow, just FYI. So hopefully that goes well. Okay, if you have any questions, you can message me on Reminds. If there's anything that you need, just let me know. All right. I'll see you guys next week.